For this video, I wanted to go over how to deal with negative numbers and negative bases, because from what I've seen in class, this can be a pretty confusing topic. To start off, I'm going to show you an example, probably the simplest example, of comparing powers with negative bases and how their exponent will affect whether the solution is positive or negative. I like to pick -1 as a base because that means no matter what the exponent is, the answer is going to be 1 or -1, because 1 times 1 is 1, 1 times 1 times 1 would be a 1, and so on. Let's start off at the top here. We know that anything to the power of 1 is itself, so the solution here would just be -1. Next, we've got -1 to the power of 2. That means we're doing -1 times -1. And when we're multiplying two negative numbers together, it makes it positive. So the answer for this one would be a positive 1. Okay, next one. -1 to the power of 3. That would be -1 times itself 3 times. So 1, 2, 3. We already know from this last example that -1 times -1 is positive 1, so this part right here becomes positive 1. I'm going to write that down just right here. Okay, so really what we're doing here is positive 1 times -1. And what do we get when we multiply a positive and negative together? A negative answer. So here it would be -1. And you'll start to notice a pattern here. It's switching from negative to positive to negative. That means next one is going to be positive 1, and the next one would be -1. Now the pattern is that when we have a odd exponent, so 1, 3, or 5, the solution is always negative, or negative. If we have an even exponent, like 2 or 4, the answer is always positive. So hopefully this helps you remember that. Remember, this only works if you're dealing with a negative base. If you have a question like -1 to the power of 4, you might think, oh hey, that's an even exponent, so the answer is going to be positive 1. No, that's actually not true, because that only applies when the base is negative. In this example here, the base is just 1. The base would be -1 if this was in brackets, then that would be true. So be really careful. This rule only applies if you have a negative base, which means that the negative sign is contained in brackets, like that. Okay, let's try a couple more examples. Let's say we've got -4 to the power of 2. Okay, first of all, are we dealing with a negative base? Yes, we are, because it's contained within brackets and the negative sign is inside it. Our exponent is even. That means our answer is going to be positive. What is 4 times 4? 16. Next one. What if it is -4 squared, like this? Are we dealing with a negative base? No. That means, in fact, let me write the expanded form of this. We're going to have a negative sign, and then this is just 4 times 4. So the answer to that would be -16. What about -4 to the power of 3? So that means we're doing -4 times -4 times -4. That would get us -64. And we know it's negative because, again, we have a negative base and an odd exponent. What if the question was -4 to the power of 3 without the brackets? So that means the expanded form would be negative sign in front, and then 4 times 4 times 4. Well, that's actually the exact same thing, right? Because this is 64 with a negative sign in front of it. Alright, here's the last one. my favorite of them all, negative 4 to the power of 3. Okay, now the easiest way I think to solve this is first figure out what this is. So we actually already did up here. We know that negative 4 to the power of 3 is negative 64. So this becomes negative 64. However, there is still this negative sign that we have to deal with. So that negative sign is still right here. So if we combine two negatives together, it becomes a plus sign. So the answer for this would actually be positive 64. So I hope these examples help. Yeah, and that's it for this video.